Good morning, class.
Good morning.
Yes, today we are going to learn about carbon and its compound. And the subtopic that we are going to deal with today is preparation of carbon for oxide. So we know that carbon for oxide it is a mere oxide of what? It is mere oxide of carbon. So if it is a mere oxide of carbon, therefore it is made up of oxygen and what? Carbon as its respective elements. Now, this carbon oxide, it is a gas that is linked by covalent what? Bonds. So if it is linked by covalent bonds, therefore it has other properties which we'll be looking at the end of this topic. Now, how can we prepare this, or we've seen carbon dioxide being used in different what areas, isn't it? For example, carbon dioxide it is used in what? In soft drinks such as your sodas that you took during the what? Your birthdays. It is also used in the what? In the fire extinguishers. Now, for us as we scientists, we need to prepare our own gas. We need to prepare our own gas so that we don't want to depend on other persons. Now, how can we prepare this? What are the raw materials in preparation of this carbon dioxide? Now, we are supposed to place a few pieces of marble chips. Marble chips, in this case, it is calcium carbonate. We need to place a few pieces of marble chips in a conical flask. After doing so, we need to rearrange this way, and then we add dilute hydrochloric acid dropwise. We need to add hydrochloric acid dropwise in this kind of case. Now, as we do so, we shall see the reaction taking place, whereby when we see that carbon it has formed, we shall see first of all the what? Effervescence, isn't it? So effervescence means that you will see bubbles of a colorless gas doing what? Evolving. So when you see those gases evolving, so under our equation is that we see that calcium carbonate, which is our marble chips, reacts with hydrochloric acid. It is what? Dilute hydrochloric acid. And this one, if it is dilute, it means that it is in the aqueous what? Kind of state. So at the end of the day, it will give us what? Calcium chloride will give us also what? Carbon dioxide gas and what? So remember, any equation should be balanced. Any equation must be balanced, isn't it? And then you must state all the what? State symbols. So we know that dilute it is in aqueous what kind of the state. So at the end of the day, it will give us what? It will give us three kind of products: calcium chloride, carbon dioxide, and what? And water. So we are not interested with the two, but we are only interested with the carbon dioxide. So how can we? This is carbon dioxide formed, and we say that this carbon dioxide, if it has been formed, we shall see bubbles of a colorless gas being what? Evolving. Now, at the end of the day, this carbon dioxide will pass through this one, these kind of tubes to go via sodium hydrogen carbonate. So, what is the function of sodium hydrogen carbonate class in this kind of the setup? In this kind of the setup? Yes, Benedictus. Is it to dry the carbon dioxide class? Not really. Any other trial? So in this kind of the case, the work of sodium hydrogen carbonate in this case, it is what? It is now to remove the traces, of an reacted what? Dilute hydrochloric acid. So the work of sodium hydrogen carbonate is to what? To remove the traces of what? Sodium, to remove the traces of unreacted hydrochloric acid. Now, this carbon dioxide is still moving within the setup. It will go via what? Concentrated sulfuric 6 acid. Now, what is now the work of concentrated sulfuric 6 acid? Because as we said, we need to do what? To dry the gas. If we want to dry the gas, we need to bubble that carbon dioxide via what? Via concentrated sulfuric 6 acid. Not any other thing, but concentrated what? Sulfuric 6 acid. Therefore, this one, concentrated sulfuric 6 acid, will act as a drying what? Agent. Will act as a drying agent. A drying agent. So the drying agent, therefore, this one will now what? Will now dry carbon what? Dioxide, isn't it? So if it dries it, therefore the gas is ready to be what? To be prepared. The gas is ready to be prepared. How can we prepare? How can we collect the gas? Plus how from the setup, because we learned in Form 1, we learned various ways through which we can collect what? The gas. So we've prepared our gas. Now we want to collect it. Which is the best method are we going to use to collect it? Yes, Isaac? We are going to use downward what? Delivery. So this carbon dioxide is now ready to be packed and then to be what? Transported, isn't it? So it is now what? Dried. So this one we collect using downward what? Delivery. Or we can say, or sometimes they say we can use what? Upward displacement of what? Air. Upward displacement of air. Now, we need to look at the properties of this carbon dioxide, because we've looked at carbon dioxide, but how can we identify that this is carbon dioxide? The gas has its own respective properties. Now, we say that the gas, before we reacted with calcium carbonate with dilute dilute hydrochloric acid, we saw that the gas evolved produced what? There were bubbles of a colorless gas evolved. So carbon dioxide, it is a colorless and odorless what? Gas. Odorless, it means that you can't smell whether this is carbon dioxide, because we are using all the senses, isn't it? We are using our eyes because it is colorless, isn't it? We use our noses, it is what? Odorless. And then this gas, it is what? It is denser. It is denser than what? Air. That is why we are collecting it using downward delivery. Downward what? Delivery, or sometimes we refer to it upward displacement of air. And then this gas, it is acidic. It is acidic in nature. Why is it that it is acidic? Because when we are testing now using two universal indicators, that is a blue and what? A red litmus paper. In this case, it turns a blue litmus paper what? Red. And then the red litmus paper remains what? Red. It clearly suggests that the gas formed, it is what? Acidic. In what? In nature. Does this gas support burning? This gas neither supports burning nor what? Combustion. So in other words, this is our carbon dioxide. Now, because these are our respective what? Properties. Now, class, today we've learned on how we can prepare what? Carbon dioxide. We say that carbon dioxide is prepared by what? By the reaction of calcium carbonate with dilute what? Hydrochloric acid, whereby it will give us three major products, but carbon dioxide, which is the one that we are interested in. Therefore, class, And then we've also looked at various properties of carbon for oxide, isn't it? And you know them at your own. So in the next lesson, we shall be looking at, in the next lesson, in the next lesson, what you will be looking at, what we shall be looking at is about the uses of what? Carbon for oxide, uses of carbon for oxide, uses of carbon for oxide, and then as we introduce other things later. And then as your assignments, you will go and read more on what? On carbon for oxide. Unless we have any question, we can answer it. Thank you.